Students, here is another problem, sample problem video on indeterminate beams with settlement solved by matrix approach. So for the beam shown, E is 200 gigapascals, I 500 times 10 to the 6 mm to the fourth. Support settlements are A 8 mm, B 15 mm, C 10 mm, D 6 mm. Compute the nodal displacements and member forces. EI here is 200 times 10 to the 6 kilopascals, because this is gigapascals, times 500 times 10 to the 6 mm to the fourth divided by 1000 to the fourth to convert moment of inertia to meter to the fourth. So that kilonewton per meter square times meter to the fourth is kilonewton meter square. So EI is 100,000 kilonewton meter square, which is this. The sideway moment formula from slope deflection equation, remember, moment is 2EI over L quantity 2 theta near plus theta far. Theta near, theta far set 0, so we have purely relative displacement due to side sway. So minus 3 delta over L. So 2EI over L quantity negative 3 delta over L is negative 6EI delta over L squared. So that's the side sway moment formula. So fixed moment AB therefore is negative because this is counterclockwise at the left. Remember from slope deflection equation, clockwise is positive. So negative 28 W L square 8 square over 12, then minus 6 EI 100,000. The difference between 8 mm and 15 mm is 7 mm, and the rotation of the chord is clockwise, so that's why 0.007 or 7 mm is treated positive here, because the rotation of chord AB is clockwise, horizontal chord AB clockwise. So 7 mm or 0.007 meter is treated positive in the formula. So negative 6 times 100,000 times 0.007 over 8 squared. So the value of the first is negative 448 over 3. The value of the second is negative 525 over 8. And since these are calculated using slope deflection equation, negative means counterclockwise. So that's why we have negative 5159 over 24 counterclockwise. So it is written positive here because the direction is 5159 over 24. Fixed end moment BA, on the other hand, is positive 448 over 3 because of symmetry. So, but this is positive clockwise, 448 over 3. But the value of the side sway moment is still negative 525 over 8. The net value 448 over 3 plus negative 525 over 8 is positive 2009 over 24. So it is clockwise because the result is positive. So as shown. Then this force AB is computed by summing up moments about B. So FAB times 8, this is the calculation. If you want to check it, FAB times 8 plus 2009 over 24, then equals 5059 over 24 plus moment of the load 28 times 8 times 4. 28 times 8 times 4. So computing for FAB, fixed end force AB, so that's 4,109 over 32 kilonewtons. Then summation forces Y equals 0, FBA plus FAB, which is 4,109 over 32, plus FBA equals 28 times 8. So FBA is 3,059 over 32 kilonewtons for fixed end forces later when we compute for the member forces. Next, for portion BC. So for portion BC, fixed end moment is, so the rotation of the chord BC is now counterclockwise. 15 mm minus 10 mm is 5 mm. So 5 mm is treated negative because the rotation of the cord is counterclockwise. So Fixed moment BC is P32 negative 32 at the left, negative 32 times 2 times 3 square over 5 square. Remember the fixed moment formula, negative PAB square over L square. Then for the side sway moment, negative 6 EI, 100,000 times 5 mm, which is negative 0.005 meter here because the rotation of the cord is counterclockwise. Remember the sign convention for slope deflection, clockwise positive. So that is counterclockwise, so negative 0.005 over L square 5 square. So the value of the first is negative 576 over 25. The value of the side sway moment, negative negative, is positive 120. So negative 576 over 25 plus 120 is 2,424 over 25 kilonewton meter. Since it is positive, so it is clockwise as shown, 2424 over 25. Fixed moment CB, on the other hand, is positive 32, 2 square times 3 over 5 square, plus 120, which will not change. So positive 3384 over 25. So positive means clockwise, as shown in the figure. 3384 over 25. Then for the fixed force BC, summation moment about C equals 0. So assuming upward, FBC times 5 plus 3384 over 25. Then since this is also clockwise, plus 2424 over 25, then equals moment of the load 32 times 3. So solving for FBC, it is negative 3408 over 125. And it is still assumed upward, but the sign is negative 3408 over 125. Likewise, summation forces Y to solve for FCB. So negative 3408 over 125 plus FCB equals 32. So FCB is positive 7408 over 125, which is this. Then finally, for portion CD, fixed moment here is W L square over 30 negative. So negative 36 6 square over 30. Then side sway moment negative 6 EI 100,000. Again, the rotation of CD is counterclockwise. The difference 10 minus 6 is 4. So 4 mm or negative is, or 0.004 meter is treated negative because the rotation is counterclockwise. So negative 6 times 100,000 times negative 0.004 over L square 6 square. So the first is negative 216 over 5. The second is 2,200 over 3. So combining, the value is positive 352 over 15. So it is clockwise. So clockwise 352 over 15. Fixed moment DC is WL square over 20, positive 36 6 square over 20. Then plus 200 over 3 side sway moment. So positive 1972 over 15. So that means it is clockwise as shown here. Summation moment about C equals 0. FCD times 6. FCD times 6 plus 1972 over 15 plus 352 over 15 equals moment of the load 1/2 636 times 2. So FCD is positive 458 over 45. Then summation forces Y, 458 over 45 plus FDC equals load 1/2 636. So FDC is 4402 over 45 as shown in the figure. Then the nodal loads would be at 1, which is A, since this is the net fixed end moment. Then the nodal load is opposite to that. So if it is counterclockwise, so it is clockwise 5159 over 24. So clockwise moment is negative in matrix structural analysis. That's the universal sign convention. So this is treated negative because it is clockwise. Then at B or node 2, the moment is, because these are supports, the vertical loads are not important. So 2009/24 clockwise plus 2424/25 clockwise. So the net moment, fixed moment at B is clockwise, and it is 180.66833 clockwise. But the nodal load is opposite to clockwise, so counterclockwise, and this is positive 180.66833. At node 3, which is C, 3384/25, then plus 352/15, that's positive clockwise. So the node is counterclockwise, and the value is 11912/75. Again, 3384/25 plus 352/15, that's clockwise. That's the net fixed end moment at C. So the nodal load at C is counterclockwise, positive, so 11912/75. Finally, at D, node 4, the net fixed end moment is clockwise, so the nodal load is counterclockwise, and the value is 1972/15, which is treated positive. So these are the stiffness of member AB, global, 12 EI, 12 times 1/8 cube, so 3/128, and you know how to generate these values already. So 1, 2, 3, 4 for AB, 1, 2, 3, 4, 1, 2, 3, 4. So next we proceed to BC, 12 times 1/5. So these were the forces. So stiffness of BC, 12 times 1/5 cube is 12/125. 6 times 1/5 square, 6/25. And the rest, you generate this. You should know how to generate this. These were the net nodal loads. Then stiffness of CD, 12 times 1/6 cube is 1/18. 6 times 1/6/1/6. Then the rest, you generate the numbering 5, 6, 7, 8. So we are interested of 2, U2, which is theta A, U4, which is theta B, U6, which is theta C, and U8, which is theta D. 2, 4, 6, 8. So 2, 4, 6, 8. Then the net nodal load, we have clockwise, so meaning negative 5.9/24, counterclockwise, positive 180.66833 at node 2, which corresponds to F4. At node 3, which corresponds to F6, positive 11912/75, 11912/75. At node 4, positive 1972/15. EI is 100,000, and 22, we have 22 in AB there, and I think it is 1/2 for 22. 4 times 1 divided by 8 is 1/2. So yeah, it's 1/2. Then 24 is 1/4. You just look at there, 260,280. Then copy 1/400. Then this is 44. We have 0.8 or 4/5 here. And 44 in member AB is 4/5. 0.8 is, I think, 1/2. So 1/2 or 0.5 plus 0.8 is 1.3. Then we have 4/6, 4/6, 2/5. So we have 2/5 here, 4/6. Then 4/8, there's no 4/8, so it's 0. And copy 2/5, copy 0. Then this is 6/6, 6 is 4/5 plus 2/3. 4/5 plus 2/3 is 22/15. That's 6/6. Then 6/8. 6/8. 1/3. So 1/3. Copy 1/3. This is 8/8. And we have 8/8 2/3. So 2/3. Therefore, we can now compute U2, U4, U6, U8, which are respectively theta A, theta B, theta C, theta D, is the product of the inverse of this matrix and this force matrix here. So the result U2, theta A, U4, theta B, U6, theta C, U8, theta D is negative 5.532637 times 10 to the negative 3. U4, which is theta B, 2.46694 times 10 to the negative 3. U6, which is theta C, is negative 4.29567 times 10 to the negative 5. And U8, theta B, 1.99348 times 10 to the negative 3. All would be in radians or unitless. We can now compute the member force of AB, shear AB, which is RA, shear moment AB, shear BA, and shear moment BA. So EI 100,000. This is the stiffness of member AB from the preceding slide. Then displacements delta A 0, delta A 0, theta B negative 5.532637 times 10 to the negative 3, delta B 0, then theta B 2.46694 times 10 to the negative 3. Then fixed forces 4109/32 positive. This is positive also counterclockwise universally 5159/24. Then FBA 3052/32 positive. Then moment BA negative 2009/24 because it is clockwise. So 3/32 times negative 5.532637 times 10 to the negative 3 plus 3/32 times 2.46694 times 10 to the negative 3 times 100,000 plus 4,109/32. You will get 99.666 kilonewtons. That's the reaction at A. That's also shear in AB. Then moment AB, which is expected 0 because this is a free end pin support. So 1/2 of negative 5.532637 times 10 to the negative 3 plus 1/4 of 2.46694 times 10 to the negative 3 times 100,000, then plus 5129/24. That is equal to 0 as expected. Then shear BA negative 3/32 times negative 5.532637 times 10 to the negative 3 plus negative 3/32 times 2.46694 times 10 to the negative 3 times 100,000 plus 3,059/32. You will get 124.334 kilonewtons. Then moment BA 1/4 of negative 5.532637 times 10 to the negative 3 plus 1/2 of 2.46694 times 10 to the negative 3 times 100,000 plus negative 2009/24. You'll get negative 98.677 kilonewton meter. Then member force BC. This is the stiffness of BC. We just grab this, copy. Then delta B is 0, theta B, delta C 0, theta C, which is that. Then fixed forces FBC is negative 3408/125. Moment is clockwise, so negative 2424/25. FCB is positive 7408/125. Then moment CB clockwise, so negative 3384/25. So 6/25 times 2.46694 times 10 to the negative 3 plus 6 over 25 times negative 4.29567 times 10 to the negative 5 times 100,000 plus negative 3408 over 125, you will get 30.912. Moment BC, 4 over 5 times 2.46694 times 10 to the negative 3 plus 2 fifths times negative 4.29567 times 10 to the negative 5 times 100,000 plus negative 2424 over 25, you will get 98.677 kilonewton meter. Shear CB, negative 6 over 25 times 2.46694 times 10 to the negative 3 plus quantity negative 6 over 25 times negative 4.29567 times 10 to the negative 5 times 100,000 plus 7408 over 125, you will get 1.088 kilonewton meter, 1.0884 kilonewtons. Kilonewtons. Then moment CB, 2 fifths times 2.46694 times 10 to the negative 3 plus 4 fifths times negative 4.29567 times 10 to the negative 5 times 100,000 plus negative 3384 over 25, you will get negative 40.119 kilonewtons meter. And finally, for member force CD, MDC is expected 0, of course. Shear CD, 1/6, these are the displacements, delta C 0, theta C, delta D 0, then this is theta D. So 1/6 times negative 4.29567 times 10 to the negative 5 plus 1/6 times 1.99348 times 10 to the negative 3 times 100,000 plus friction force 458 over 45 positive, clockwise, so negative 352 over 15, then positive 4402 over 45, then clockwise, so negative 1972 over 15. So 1 over 6 times negative 4.29567 times 10 to the negative 5 plus 1 over 6 times 1.99348 times 10 to the negative 3 times 100,000 plus 458 over 45, you'll get 42.686 kilonewtons. Then for moment CD, 2/3 times negative 4.29567 times 10 to the negative 5 plus 1/3 times 1.99348 times 10 to the negative 3 times 100,000 plus negative 352 over 15, you will get 40.119, which checks here. Then shear DC, negative 1 over 6 times negative 4.29567 times 10 to the negative 5 plus negative 1 over 6 times 1.99348 times 10 to the negative 3 times 100,000 plus 4402 over 45, you will get 65.314 kilonewtons. Then finally, 1/3 for moment DC expected 0, 1/3 of negative 4.29567 times 10 to the negative 5 plus 2/3 of 1.99348 times 10 to the negative 3 times 100,000 plus negative 1972 over 15, that is 0. So that's it for this video. I hope that you were able to follow the solutions and understand the explanations.